When I first became CEO, one of my frustrations was I'd go see customers and they'd be like, oh, I've got your software code right here. And I was like, why isn't that CD installed on your computer being used to solve a problem? Or why isn't that prototype actually in the lab being used to test devices? So that's kind of where one of the ways that model came out is not only are we going to develop the product, we're going to install it on the computer and we're going to provide you with the engineers to run it for you.
Thousands of companies show up to sell their technology to the U.S. Department of Defense each year. But so few will transition from proof of concept to true production across the valley of death. The select few who do, their stories are rarely told. Until now. I'm Noah Scheinbaum, and this is Crossing the Valley. CFD Research started in the Singhal family garage in 1987 in Huntsville, Alabama, a few years after Ashok and Sangeeta relocated from the UK. Today, the company is led by their son, Sameer, who has grown it to over 250 employees and more than $100 million in small business innovation research funding. The company has a dynamic business model, developing and commercializing hard tech, sometimes licensing and spinning out what it develops. In the past few years, CFD also became 100% employee-owned. In this conversation, I sat down with President and CEO Sameer Singhal to talk tech, commercialization, and building for national defense. All right, Sameer Singhal, thank you so much for being with us. Welcome to Crossing the Valley. Really excited to have your first podcast interview today.
Thanks, Noah, for having me today.
Absolutely. So CFD Research is probably one of the bigger and more successful defense technology companies that a lot of folks listening may have never heard of. And so, Sameer, I would love to start with a little bit about the company. Just tell us, what is CFD Research? What do you all do?
Sure. I think you put it in a good way. I mean, CFD Research really is an innovative small business that prides itself on creating innovative technology solutions for our government customers. The company was actually founded over 36 years ago in 1987 in our basement. My parents started it in the basement of our home when I was in elementary school. I actually made the first sign for the company. It's actually back there behind me if you can see it. It's a dot matrix sign that says CFD Research Corporation that I printed in 1987. But right from the start, we've been fostering that innovation and transitioning technology to the field.
So they started it in the garage. I mean, this is almost a Silicon Valley story, but you are not in Silicon Valley. Tell everybody, where is the company based and where were you living at the time?
Yeah, so we're located in Huntsville, Alabama. So, Huntsville is a big town for both NASA work as well as DoD, Army, MDA, SMDC, even the FBI now all have headquarters here in Huntsville. The company's first project actually was the Challenger solid rocket booster redesign in 1987. As your listeners probably know, in 1986 was the Challenger disaster. And CFD Research, one of our first projects really was helping to redesign those solid rocket boosters and help the space shuttle return to flight. And we also aided in the Columbia return to flight mission in 2003.
That's pretty amazing. Yeah, I know from tragedy and disaster came, I'm sure, quite a bit of opportunity in the space world. What were your parents' backgrounds? What made somebody in 1987, still Cold War, the Soviet Union's not yet collapsed, but what made your parents at that time decide this was the industry and this was the way to go?
Yeah, so my parents grew up in India. My dad actually did his PhD at Imperial College in London, England, which is actually where I was born when he was finishing his PhD. His PhD was in CFD, so the company's name, CFD, that actually stands for computational fluid dynamics. We do a lot more than just that now, but that's an innovative modeling technique of modeling fluid manipulation. It's brand new in the 80s when he got his degree. What a lot of people don't realize is that air is actually a fluid. So, in aerospace, when you're talking about rockets, space shuttles, missiles, you're modeling airflow around those vehicles. So that's really where they started on, was using those CFD techniques to model airflow around these rockets and missiles. After he graduated, my dad's advisor at Imperial College wanted to start a branch of his company in Huntsville, Alabama, mainly, again, because of NASA, Marshall, and all the space work in Huntsville. So my dad actually moved the family from England to help start that branch of his advisor's company in Huntsville in 1978. And then later in 1987, he decided he wanted to start his own company.
So from London, from the UK to Huntsville, Alabama in 1987 is probably not the most logical or smoothest transition. What do you remember as a child about making that transition?
Well, I don't. I mean, I moved here when I was like between 1 and 2, so
Yes, not
I
much.
don't. Yeah, I pretty much. Yeah, I've lived in. I always say I've lived in Huntsville pretty much all my life.
Yeah.
I did move around. You mentioned Silicon Valley. I went to my undergrad at Georgia Tech in Atlanta, and then I went to grad school at Stanford in Silicon Valley and lived there for a few years, and then I was at a semiconductor startup in Raleigh, North Carolina for about 8 years before I came back to Huntsville.
Yeah, so you're well traveled in the company today. You all have offices not just in Alabama but also Ohio and Florida, right? So
Correct. We have an office in Dayton, Ohio, right outside Wright-Patterson Air Force Base, and then one in at Eglin Air Force Base in Florida in the Panhandle. And we actually have an office in Hollywood, but it's Hollywood, Alabama, which is a rural community about 45 minutes east of our headquarters in Huntsville. But we have a large test facility out there.
That's awesome. So you started to tell a little bit about your background and where you've been. Talk to us about your decision to come back to the family business. When did you make that jump and why did you do it?
Yeah, so there's a few things that happened. So, when the company was started, like I mentioned, it was all CFD, a lot of modeling and simulation, and very specific to the aerospace industry, which I liked, but I had other interests as well. My interest and the company's interest kind of just naturally started aligning more in the 2000s. So I mentioned CFD is computational fluid dynamics. So we started by simulating airflow over rockets and missiles. We had an engineer, same guy who simulated the Challenger solid rocket booster project. He decided he wanted to start simulating blood flow in heart valves, which is still a fluid. So that's kind of how we started doing biomedical work. And then we started doing energy work, which was like fluid management and water management and fuel cells. And then we started doing more electronics work, which is actually the industry I was in, was semiconductors. So looking at like heat mitigation for semiconductor devices. So the company started broadening, and we also started an experimental arm because, for the first 10 years, the company was purely modeling and simulation, but then we started doing our own test and evaluation to validate the simulations. And then ultimately we started prototyping and fabricating our own devices too. So I think just the growth in the company and to align more with my interests, which are more on the experimental side and more in electronics and energy, that helped a lot. And just to be completely blunt, we had our first child, my son, Akash, in 2007, and we wanted to get closer to family instead of being 12 hours away from everybody. So that played a role as well.
Wonderful. So Sameer, so your decision to come back to the company as you all evolved from fluids in rockets to fluids in heart valves and biological systems. How did you re-enter? Did you come right to the top, or did you do other jobs in the company?
No, that was always one of the big things that me and my dad talked about. Neither one of us wanted that. So I actually started as a group leader, which is basically our first level of management. I think I was a group leader for maybe 2 years, and then I became a manager, then a director, and then I think I became a vice president. So I joined the company in 2008. I think I became a vice president in 2013, and then I took over as president and CEO at the end of 2016.
Okay, so a number of years working kind of at different levels in the company, and still a small business in terms of number of employees, right? Today, how many employees do you all have today?
Yeah, so we have 254 employees today, but we've grown quite a bit. When I took over in 2016, we were about 75, 80 employees. So we've grown quite a bit. We crossed 200 employees in 2022 and then 250 last year in 2023.
Yeah, so tell us a little bit more about the team on that side of the model, because it's interesting. You all have not raised, another example of a company has not raised outside capital. You started in the garage, kind of a family business at its core. What does the team look like today, and what's special to you all about being a family-owned business?
So I think the team is the single most important thing, and we take a lot of pride in hiring the best of the best. But I always want to say we don't want to stop there. We want to give our employees the resources they need to be successful, and we want to empower them to be successful. I still meet with all new employees their first week in the company for 15 minutes. And one of the things I tell them is that my job as CEO is to facilitate their success. Anything I can do to make their life easier, whether it's, reviewing one of their proposals, introducing them to a customer. Again, that's my number one goal is ensuring our employee success. And, if they're successful, the company will grow and be successful.
And you all have done, you've taken another step to kind of demonstrate the importance of the team. You're all now an employee-owned company, right? Employee ownership. Talk a little bit about that decision and transition.
Yeah, I'll talk about that, and I might go back a little bit of a history lesson again. So from 1987 to 2004, the company was we had a commercial software product that we sold, and then all the profit for the company essentially went back to helping grow and sell that product. We ended up selling off that software division in 2004 to an international software company. And then from 2004 to maybe 13, we really concentrated on just doing contract R&D for the government. At that time, my parents made the decision that since the company's growth was really 100% function of the employees and their hard work, their ability to write proposals, win work, execute work, keep the customer happy, they decided they wanted to share ownership in the company with the employees. So we transitioned to a partial ESOP. ESOP stands for Employee Stock Ownership Plan, and essentially every employee is given a percent of ownership in the company. And we've been growing that organically for the last 15 years, to the point that we crossed 50% ESOP ownership in 2020. And then just last year, on October 2nd, 2023, we finally made the decision and we went 100% ESOP. So now every single employee has ownership and there's no owners outside of the ESOP. So again, we really feel like it's rewarding our employees directly for the growth they create in the company. We get a stock price evaluation once a year, and the employees get to watch that stock price go up. And I always tell them it's nice to own something where you have direct control. They might not feel like they have control because they're not running the company, but they're one of 250 employees that's working every day to help that stock price go up. And then from a customer standpoint, we always say that we want our employees to treat our customers like owners would, because they are owners. So we think it adds that extra level of dedication and professionalism that, again, just kind of helps catalyze and helps continue that growth even faster.
Absolutely. No, it's about aligning incentives, and y'all are it's a tough industry. There's, as we all know, and the competition for talent, especially today, is quite fierce. So I think doing that is really interesting. It's taking a page from, some would call it a Silicon Valley playbook. The difference is your cap table doesn't have any external capital on it. It's just you all, which is, I think, pretty unique. So one more thing on the team before we kind of move into how you all work. Who works at CFD Research? What is a CFD persona? What does a CFD employee look like versus somebody who just would not be a good fit?
Yeah. So we actually did, I think it's called a word cloud, but we asked all our employees, like, if they could describe CFD Research in one word, how would they describe it? And we've done that a couple of times, and every single time the word that always wins out is innovative or innovation. So our employees at their heart are just naturally curious, naturally innovative, continuous learners. They're not willing to just say, oh, this is the way it's always been done, so we're going to do it this way. We do have a very high percentage of PhDs. I think we have over almost 60 PhDs on staff, so about a third of our staff is PhDs. But again, more than just the higher education, it's that curiosity, that wanting to find a better way to do things, just that natural passion about their research fields.
Natural curiosity is a good place to start. I love that. And so that team, highly educated, highly technical, highly competent, is employed in a couple of ways, right? You all have a pretty interesting business model. And as we start to think about what transition looks like, and as we start to think about the different ways that companies sell into the defense market, you all basically have three kind of paths to commercialization, or what we would call in this program transition, right? And that's you license product, you spin companies out, and then you do sometimes kind of in-house commercialize. So Sameer, can you walk us through that business model and how it's evolved, and kind of how you all think about the portfolio of opportunities available to the things that you develop?
Yeah. So one of the things I always like to say is that, we do really cool R&D projects, but I always want to make sure we're not doing research for the sake of research. So we take a lot of pride in seeing our technology transition to the real world. So there's a few different ways we do that. One way, even, before I get into the three ways you mentioned, is we actually embed our scientists and engineers at the customer site sometimes, subject matter experts working shoulder to shoulder with a government customer, solving really hard problems. So as an example, with NASA Marshall, we have about 15 people who sit on the second floor of the building I'm in. They develop really cool software tools in our facility. We install them on the NASA supercomputers, and then we have our 12 employees who sit at NASA Marshall, and they use those software tools, again, working shoulder to shoulder with a government customer to design acoustics on the launch pad of SLS, the Space Launch System for the Artemis missions, or looking at sloshing in the propellant fuel tank. So that's one way we get technology out into the field.
Just, Sameer, before you move off that, I just want to clarify that. So you all build the products and you have forward deployed engineers or forward deployed team members who are the ones using the products. So you're designing products that your folks also are the ones operating.
Yeah, so maybe a small detour, but when I first became CEO, one of my frustrations was I'd go see customers and they'd be like, "Oh, I've got your software code right here," and they wave a CD in my out of their desk drawer. They'd point to their shelf and say, "Oh, your prototype's on my shelf." And I was like, "Why isn't that CD installed on your computer, being used to solve a problem? Or why isn't that prototype, actually in the lab being used to test devices?" So that's kind of where one of the ways that model came out is not only are we going to develop the product, we're going to install it on the computer and we're going to provide you with the engineers to run it for you. So similarly, we have probably over 30 engineers who support the Army in different capacities, but going into classified labs, sometimes with our software tools, sometimes just using Army tools, but solving, really hard problems for the government.
Very interesting. It's a model that you sometimes hear. I mean, I think Palantir in the kind of the big tech ecosystems popularized the notion of a forward deployed engineer. But even then, I think it's different between having folks in the customer environment teaching a customer how to use it versus actually having your folks there operating the tools. So that's a really interesting model, and that's just part one. Let's go into the other options.
The product side. So again, I was kind of telling you earlier that from 2004 to 2012 or 13, we really did what I call contract R&D. So these government contracts. I'll be honest, it wasn't my idea or any brilliant idea from the executives down. It was really the employees bubbling up saying, "Hey, we've got this really cool technology we developed for the Department of Defense, but we think there's a dual use for this technology and there's a commercial market." And they were really the ones who came to us and said, "We'd like to find ways to get this technology out into the field, helping other people." So that's really how the focus on the products arm came. We've always had a lot of patents. We have, I think, over 85 patents that have been awarded. So the first thing we started really trying to do was commercialize those patents through licensing agreements. So, you basically find somebody in the market space, you license the technology to them, and then we get royalties for every product they sell. But more importantly, you're getting the technology and that patent out into the real world. So I'll give you one example on that front. We developed a thermal battery technology. So thermal batteries are batteries for missile systems. So they have a solid electrolyte. You essentially melt the electrolyte when you want to turn on the battery, and then the missile's able to fire. The challenge with missiles is, that missile sits in a silo for 20 years, and it's got to have 100% of its charge in 20 years. It can't be like your iPhone battery where it self-discharges, over time. So that's the reason. Very specialized batteries. They typically operate at 1.8 volts per cell. We actually developed a new technology that operates at 2.5 volts per cell. So now when you stack them up, they look like a soda can. When you stack them up to get your 28 volt to 56 volt battery, our batteries are about 40% shorter, less volume than a traditional battery. So we started that technology in 2012 with the Small Business Innovative Research Program, an Army SBIR grant. We developed the technology, proved it. We actually licensed it to the largest thermal battery manufacturer in 2018. And now they're actually selling product to major defense contractors and it's getting ready to fly in active combat zones. So I always joke when they sell a battery, it's got a CFD Research Inside sticker on the outside of the battery. And there's no actual sticker, but we do get royalties for every battery they sell. And maybe more importantly, the technology is out in the field helping our warfighter achieve their mission every day.
It's a great story, and it's something that you really don't hear a ton about in defense today, which is that you don't, there's a really good, not only technical model, but business model around focusing on a problem, building a really impressive and meaningful solution, and then handing that off to somebody else that might be well positioned to actually do the sale. Or whether they have an existing program and contract where they can kind of put that component into play, or they have a relationship with a customer that makes it kind of easier for them to do it versus you. Maybe, Sameer, I am curious, why on this particular technology did you all decide to license as opposed to take it to market yourselves?
Yeah, so there's probably 2 or 3 reasons. One is it is a government market. So, we seek to form the spinouts and things more if we're going to go after a commercial market. This is the government market. I was mentioning it's fairly limited. This battery technology is really only for missiles. So there's realistically, there's 5, 6, 7 customers for the technology who actually make missiles. And then probably the single biggest reason, it's very capital intensive business. So lithium is flammable in air. So if you're making batteries, you have to have dry rooms, which basically think of the Intel bunny suit, but it's essentially a room where you suck all the moisture out of the room so that you don't have that risk of flammability. But building a facility like that, maintaining it, getting the safety training, that capital investment coupled with the limited number of customers was really the reason we decided to license in that case. But yeah, that's one of the big questions. Like every technology we seek to get out into the real world, we actually have a process we call beyond phase 2. So you do an SBIR phase 1 grant, small pilot program, 100,000 or something, prove it works, and they give you a larger phase 2 contract, typically $1 million-ish. But to me, every single one of those phase 2s is a golden nugget. And going back to that, not wanting to do R&D for the sake of R&D, we look at every single one of those phase 2s as a management team, and we actively talk about how can we take this to the next level. Is it a patent and a licensing agreement? Is it something we commercialize and sell from within CFD Research? Is it a new company that we spin out to get that technology out into the real world?
Yeah, no, very interesting. We'll come back to that process for sure, and your use of the SBIR program. Before we move off this thermal battery example, when you were looking at commercialization partners, how did that work? Was that somebody approaching you? Was that you all going out and developing those relationships? How did that work?
There was a little of both. I mean, we did have our government customer, our SBIR program manager, who kind of told us, these are the different people that we buy batteries from, and you might want to talk to. Again, relatively small space. Maybe this isn't the best example, but there's really only 4 manufacturers for these type of batteries, so the list is relatively small. You start contacting them all. Believe it or not, most of the initial connections were made at conferences. So we would go to all the the power and energy conferences, the military power conferences, and you'd see the different suppliers there. And then it's really just a matchmaking game. We've got the technology, seeing which of the manufacturers is interested and able to integrate it best into their flow.
So all right. So we got a plug for conferences. It's not just all happy hours. There's real business being done. That's good to know. And then 2, talk us through that process. So I think people, you can research, you can kind of learn what the process is to go through a government test and evaluation process. What does it look like to go through that process with a company? What are the stages from that first touch point to them saying, yeah, you know what, we actually want to integrate your battery into our solution?
It's a lot of work, and that's maybe that's one of the misnomers with the SBIR program, and also one of the things we struggle with. I talked about we hire really innovative people, we hire lots of PhDs. At some point, you've got to augment the really smart technical people with the ones who are willing to go to the conferences, it wasn't easy. It was probably 15 or 20 meetings with that company. So it's not like you have one meeting and everyone's happy and they walk away, So it's that, I guess I'll use the word tenacity. It's that tenacity, staying in front of that company and not giving up. So I think, we do have a dedicated, we've got a business development team. We actually have a vice president of technology commercialization whose whole job is to look for ways we can license our patents, ways we can commercialize technology. So I think it's augmenting the really smart PhDs and scientists with a little bit of a more business savvy team that's willing to help them find connections, make connections, and more than that, stick with it and see it all the way to the finish line.
Yeah, absolutely. And does the program that they go through with the company, does it kind of mirror what you would go through in the government with a kind of a pilot and then expansion? Is it just writing a proposal? What, like nuts and bolts wise, what does it take to kind of get that company to yes?
Yeah. So our program, I was touching on the Beyond Phase 2 program. It's about each principal investigator who runs the program spends about 20 minutes briefing the executive team, essentially, and the BD team. But I always say it's only about 3 or 4 minutes on the technology, and then the rest of the 15 or 20 minutes is all about who can use this technology and kind of who do we need to meet with on the, I guess I'd say, the product side or the commercial side, and what's the next step. And then same thing, when you're talking with a customer, the potential licensor, and this is really hard for a lot of people to understand, you've got to talk about the technology, but you really got to talk about how the technology helps them. And I think, again, that's not, rightfully so. People love to talk about the technology and how it works and voltage and power. But at the end of the day, you've got to translate that to how it actually helps the person you're trying to sell to with their business model.
Yeah, no, absolutely. One last question on this example, and then we'll move to the next model. A lot of companies listening to this show and folks who are considering how they do business, either with the government or with other companies, they think about things like IP rights. They think about things like legal negotiations and contracting. When you all, for a licensing agreement like this, how much of this is take it or leave it terms kind of handed to you by a company versus a give and take, or terms that you actually put forth?
Yeah, so I'm not going to claim I'm an expert. I've only done this 2 or 3 times, but what I've found is that these bigger companies, although they want to have the final say, they're really looking for someone to give them an answer or a proposal, put something out for them that they can beat up. If you're waiting for them to give you a proposal, you're probably going to be waiting a long time, if not forever. So we always joke about napkins. I'll be honest, this agreement, I literally wrote it on a napkin at a conference, and I gave it to the VP. And that napkin is probably 90% of what was in the final licensing agreement. So one of my strategies, partly to save money, but more to save time too, is if you can agree on a term sheet, engineer to engineer or executive to executive, before you get the lawyers involved, and just tell them to turn that term sheet into an agreement, it's a lot easy. It just tends to go faster. Again, I've done it a few times, not like 100 times, but the 3 or 4 times I've done it, that seemed to expedite things.
It's a really big insight, Sameer, and I don't want to shortchange it, which is that agreements cannot just be left to a legal team. Agreements
Right.
done by the principals, whether it's an executive or an engineer, technical lead on something, have a much better chance of getting to the finish line than if you just punt it over
Right.
to a legal team to draw it from scratch. So no, I love that. Fantastic. And this is just covering the licensing piece of your business.
Yeah.
So
Yep.
let's move now to kind of the next part, which is around spinning out companies. And what does that look like? When do you all make a decision to do something like that?
Yeah, so spinning out companies, so we had a interesting way we went about doing that. So again, this is really looking for a dual use. So we designed the technology or the product for the government, for DoD or NASA, and then is there a dual use in the commercial market? So we ended up coming up with something we call the Innovation Accelerator, and we train our employees. Essentially, they go through the business model canvas process, which was developed by Stephen Blank. So we go through that process with our employees, and we actually essentially have them come up with business plans for this, again, commercially developed or government developed technology. How does it fit into the commercial world? And we culminate that activity with basically a mini Shark Tank type event where each potential company founder pitches for 15 to 20 minutes. We bring in external judges, so you don't want any of the executives or anything judging because they all have their own, favorite technologies and things. So we bring in external judges from local accelerators, so maybe an IP attorney in town or someone who successfully started and exited a company, just, friends in the community, essentially. You have that entrepreneurial spirit. Again, these pitches are very, very market and customer centric and very light on technology. You can talk about the technology for the first 3 or 4 minutes, but it very quickly pivots to who is the potential end user, what is the market size, what are the barriers to entry. And then, like I said, we let the sharks grade the projects, and then they give us the scorecards. And I'll be honest, we don't just take those scorecards and just say, okay, this one got the high score, we're going to pick this one. We do have to kind of see who's the founding team, do they have the time to do this, how's the technology protected, going back to your question about IP and patents. But we end that Shark Tank competition by awarding teams something on the order of $100,000 in IR&D, internal research and development money. Again, that money is primarily used for customer interviews, so to find customers, maybe to set up an initial website, and really to set up a fundraising deck so they can actually raise angel money from external investors. So we have several of those. We have 2 that I would say are maybe more mature right now. We have one that's a virtual physical therapy application. So we did a lot of work for the Army and NIH on soldier protection and soldier rehabilitation. So looking at injury prevention for soldiers. So back pain for helicopter pilots, shoulder pain for those shoulder-launched weapons, neck pain, and they're wearing batteries and things on their helmet now that's causing neck strain. So biodynamics, human dynamics in general. So we took those models, and we actually helped develop exercises that physical therapy patients could do, and we gamified it. So it's essentially a game you play on your cell phone or a tablet. You set up this tablet at your home, and then you do exercises. You move your neck or you shake your head. But the beauty of it is the physical therapist gets a report to tell you how long you've been exercising and the range of motion. Because the biggest problem in physical therapy is your doctor gives you all these exercises. You come back to see him 3 weeks later. He's like, "Did you do your exercises?" And you're like, "Yeah, sure." And he has no way of telling if you actually did them and if you did them seriously or did you just kind of like move your neck around while you were watching TV.
I don't know if that's just a physical therapy problem. I think it's a human problem with accountability and doing what we intend. Very cool.
So that company's called TheraVista. We partnered with a venture studio out of Nashville, Tennessee, and they invested capital money in the entity. But more importantly, they brought in a management team who had experience in that field. They essentially brought in a CEO from the healthcare world to help navigate that. So we provided the IP, the technology, software, and then they brought in the management team and some money to help get that company going. So
really interesting. What stage are the company is the technology when it goes through the kind of internal innovation accelerator? Is this something that you've completed like an SBIR on, or is it just a kernel of an idea? What's the stage of development?
It depends. I mean, usually there are products that we completed SBIRs on, but not always. I mean, one of our technologies, just one of our employees had a personal experience in grad school, and he had this idea that he brought with him from grad school. And CFD Research as a company actually never did any work in this area, but we helped him found the company and put some resources behind it because we just thought it was a really unique idea. So that's probably more unusual. Most of them are technologies that have been through at least an SBIR phase 1, if not phase 2, but doesn't have to be that alone.
Yeah. Very cool. And then when companies get that 100K IRAD allocation, how much individuals get that amount of money, how much of their time is then spent on this concept? Does this become their full-time job, or is this kind of an extra 10 to 20% of their time type of thing?
It's kind of an extra 10 to 20% type thing, at least initially. And, then again, when they find the company market and when they're able to raise the funds, they kind of choose, do they want to go with the spinoff company? So we formally spin off the company. So TheraVista is a C corporation. Like I said, this venture studio in Nashville owns a percentage of it. CFD Research owns a percentage. And the founders, the CFD employees who helped found the company, own a percentage. And, if you actually leave CFD Research and join the company as not only a founder, but as an executive, essentially, then you get even more ownership. So we give our employees a choice, no hard feelings either way. I mean, again, to be honest, it's kind of cliche, but going back to helping our employees pursue their passions, we want our employees to work on what they're excited about. And if that means leaving CFD Research and going with one of these spin-off companies, then, we happily help them make that transition.
That's a very cool program. It's something that I think a lot more companies would do well to take a look at. So really neat. All right. So Sameer, we've now talked about 3 models, the kind of services, embedding, licensing, and spinouts. Let's go to the last one, which is you all do commercialize some technology in-house. You do support it and kind of transition it to full kind of programmatic support within the Defense Department and beyond. Talk about that process. What does it look like for you all?
Right. So probably one of the best examples there is a program we have doing ground test support for hypersonics. So again, this started as an SBIR, actually with the Air Force, probably 2010, 2012 timeframe. They have these wind tunnels for testing hypersonics weapons on the ground in Tullahoma, Tennessee at Arnold Engineering Development Center. So they contracted with us to help fix an issue with one of their wind tunnels. So there was a combustion air heater, so we were fixing a combustion instability, so essentially swirl and recirculation in the flow field. So we helped fix that problem by designing new injectors, and we enabled that wind tunnel to go from Mach 2, which is where it was limited, all the way up to Mach 7. They gave us a follow-on program, and we've been actually fabricating and delivering injectors. So there's 37 injectors in one of these tunnels. We've been delivering injectors to AEDC in Tennessee, and we've probably delivered close to 350, 400 injectors now for the different Mach numbers. But maybe more excited is what that's led to. It's led to a new project with SMDC, the Space and Missile Defense Command here in Huntsville, where they contracted us to develop a new way of of generating hot air to make the testing environment even more realistic. Higher Mach numbers, higher run times, and cleaner air. So we've gotten over $100 million actually in follow-on contracts to develop that facility. I was joking about Hollywood, Alabama earlier. So we have a facility in Hollywood, Alabama. It's about 45 minutes east of Huntsville. We built that in 2020. We procured about 10 acres. We put a 13,000 square foot building up, and we built I'll call it a small test stand with 2 test bays so that we could do, very small test samples. Within a year, we had expanded to 74 acres, and we built a second test stand that's 4 times bigger than a larger test stand. So now that can test, I'll just call it medium scale components. And we're currently finishing construction of a 20,000 square foot expansion. So by the end of the year, we'll have about 35,000 square feet, over 25,000 square feet of high bay space, large CNC machines. So we fabricate all our own materials for the test. But really, that's allowed us to do a couple of different things. We're actually able to test TPS materials, thermal protection systems. So these are essentially the coatings that go on hypersonic weapons or that go on rockets or even planes that help protect from these really, really high temperatures. These things are moving really, really fast and generating a lot of temperature. So we're able to test on the ground. So we modeled it, then we tested on the ground at our facility in Hollywood. What temperature and time and flow conditions does this thermal protection system start breaking down at? And then the ultimate goal is to put it through a flight test, but flight test resources are extremely limited and extremely costly. So the more you can do on the ground, the better.
It's a great overview of a really important program. It sounds like an incredibly, technologically complex challenge. When you think about how that, so just the on the tactical side of this started as what? Also an SBIR?
It did.
Okay. And what did it look like for you all? I know you all are pros at this. I think I saw the number. It's over $100 million in SBIR funding over a period much more than 10 years. But you all are probably one of the leading lights in terms of going from SBIR to commercialization. What did this particular one look like in terms of the stage gates, or taking the government on a journey from, hey, this is a theoretical capability that we could build to something that they are actually using in test and evaluation and in production?
Yeah, I think to me, it's really looking out for your customers' needs and going back to that, making an impact on society and not just doing R&D for the sake of R&D. So again, the first thing we developed was a new injector for reducing the combustion instability at the wind tunnel in Tullahoma. That was essentially the end of the phase 2. We could have washed our hands and said, here's your design, here's one single unit, you can put it on your shelf. But we were like, if you give us some more money, we can actually fabricate these injectors for you. We can drive them to Tullahoma, we can install them, we can make sure they work. So that was our first follow-on contract with that customer. And then very quickly, we started realizing the next problem they were having was test time. Like, it was taking them a week between tests to switch from a Mach 3 test to a Mach 5 test. So now the program we're working on is there a way to make the injectors adjustable? So you can just basically turn them and adjust them from Mach 3 to Mach 5. So now your downtime or whatever, instead of waiting a week between tests, you can do it in a handful of hours, really. So again, that's not usually something you think of in the SBIR program, or it doesn't sound super innovative because it's almost logistics, but it's super important, right? If you can be testing 5 times a week instead of once a week, I mean, that's like a game changer to the community. So it's really, when you're in there with the customer, what is their actual challenge? Whether it's designing something really cool, or whether it's just the logistical challenge they're having, and how can you make that better? And then, with the Space and Missile Defense Command in Huntsville, they really wanted to put a ground test asset at Redstone Arsenal in Huntsville. There's not any ground test facilities in the state of Alabama. So that was how the program started. And, we were realizing some of the challenges with commissioning a facility on Redstone. So we were like, why don't we start? You've probably heard the phrase crawl, walk, run. So why don't we crawl? Why don't we build a small scale facility in Hollywood and prove it works while we're getting everything lined up on the arsenal? And then it turned into, from crawling to walking, let's build a medium scale test rig in Hollywood. And oh, by the way, now you can run tests on the small scale test rig to help your potential TPS suppliers like grade their material and help your programs grade their material. And still, the ultimate goal is to run and to build a facility on Redstone Arsenal and turn it over and let it become a government asset, which we're more than happy to do. But not just sitting back and saying, okay, yeah, we're going to wait 6 or 7 years for this facility to exist on the arsenal. What can we be doing in the meantime to help the government accelerate testing and development of these hypersonic systems?
Absolutely. And for you all to be talking about facility construction and things like that, it sounds like CFD is putting up some of its own money in this process, right? Or are those facilities fully funded by a phase 2, $1.2 million SBIR, or is there, you all are taking on some?
Yeah, so the buildings, obviously, the high bays we own, the CNC machines, the construction of the test bays, that's all capital investment that CFD Research has made. Now, the actual like hypersonic test rigs and all the materials that goes on the rigs, that's funded through the government contracts.
Right.
Yeah.
Right.
Yeah.
But it's not, it's interesting because you all are putting money up against, you're not looking for venture returns. Again, I just keep coming back to, I think the financing model.
But same thing, like the CNC machines, every time they ask me to buy a new machine, we do kind of a cost benefit analysis, and we're like, we can keep sending this money out to third-party manufacturers to make it, but we could probably make it ourselves cheaper. And more than cheaper, it's always time. Yeah. Like if you send a drawing out and have somebody make it, you're waiting a long time. And we don't tend to make hundreds of anything. We make 5, 10, 15 of something. So again, the third-party manufacturers aren't giant fans of that business model. But then what we're doing is, now that we have the capital investment, we own all these CNC machines, we're actually doing machining services for other companies like us, people who need onesies, twosies, and even government customers. Even the Army's using our facilities sometimes to make parts for them. So now it's almost become, almost like it's all product line is doing machining services for people. And again, we haven't quite gotten there, but now that we have these 4 test bays and all this land and the staff to run the tests, we want to run test services essentially as a product line for other companies and potentially government entities. So, yeah.
It's amazing, isn't it? Every rock you turn over, each new opportunity, there's like 3 new potential businesses that drop out of it. It's so cool. I mean, this is my favorite kind of type of conversation to have on this show and in general, just these non-obvious businesses that are amazing businesses. They meet real mission needs. They're interesting, hard problems to work on, and they're not the things that get covered about in the mainstream media, where you're not going to read about this necessarily on the front page of the Washington Post. Doesn't mean it's not a great business. Doesn't mean it's not hugely valuable to the mission. Doesn't mean it's not a great project to work on. So kudos to you guys, Sameer. As we start to kind of move into the forward-looking portion of this, you all are masters of the SBIR program, but you also have you're on other government contract vehicles. You have kind of a whole array of contracting tools in your toolkit. How do you think about just broader go-to-market in the federal space? Is SBIR the entirety of the strategy? Is it a part of the strategy? And when do those other vehicles come into play?
It's a part of the strategy. One of the nice things about the SBIR is it allows you to use that innovation and explore those early stage ideas. So a lot of our innovation still comes through the SBIR program, but I mean, we do a lot of work through OTAs now, other transaction authorities. We have these large IDIQ vehicles. Again, I mentioned, I think about 65 of our 250 employees actually sit at a customer site on some kind of direct support contract. Some of them direct with us. Sometimes we're sub to a prime contractor on those contracts. I mean, contracts are obviously super important, and you can't do work without contracts, but I like to focus more on the technology, and then the contract is just a means to an end of getting the technology out into the field, So I'm going back to the work in Tullahoma. We use a number of different contracts, SBIR follow-on programs and other contracts. But again, it always starts with, hey, we developed this. It helps you test at Mach 6. Why don't we make this for you and install it for you and make sure it really works? And, hey, why don't we make the ones for you at Mach 5 and Mach 7 now? And, hey, we notice you're having a hard time at test time. Can we find a follow-on contract so that we can help adjust this nozzle so that it reduces your the downtime you have in between tests, So it always starts with the idea, and then you find the appropriate either addition to your existing contract or new contract mechanism to make it happen. So.
With the explosion in interest in SBIR over the last, call it 7 years or so, what do you think what is something that a lot of companies or a lot of investors get wrong about the SBIR program?
I think the SBIR program, I mean, again, I think the goal is really to get technology out into the field. It's not just to develop something cool and then leave it on the shelf. So that's one misconception. And then I think the other thing is just the pull from the customer and the integration with the program officers. I think some of the shifts in the SBIR program have been more towards just open topics, and we just want to like foster innovation, which is nice. But I think one of the SBIR is really applied research, so I think connecting it more to the end users, the program officers, and getting pull for what they really need, and then developing those solutions is super important. And I'll be honest with you, the two programs I talked about, the thermal battery and the ground test, neither one of those SBIR topics is what actually ended up making it into the field. So the thermal battery program was supposed to be looking at a new anode, the negative side of the battery. And halfway through the program, we realized that there was actually more potential to influence the customer's mission by working on the cathode, the positive side of the battery. We showed our customer, technical point of contact, why we thought that was true, and we got his blessing to start focusing on the other side of the battery. And the same thing on the ground test program in Tullahoma. That program was funded to look at laser ignition, but we were like, we think there's more bang for your buck by fixing your combustion air heater. Again, we showed all our data to the customer, ran it by them, got their permission. So it's not blindly following the topic and doing what it said, but really listening to your customer and building that, we call it a trusted advisor relationship, but building that trusted advisor relationship with your customer and then looking out for what's in their best interests.
It's vintage Steve Blank. It's vintage customer discovery, right? What the customer tells you they need or they want is not always and is rarely the final solution. Very on target. Sameer, as you look back at your time leading CFD, what have you learned in running this company? What do you wish you knew when you started?
So one of the things my dad told me when I first took over is that every business is a people business. Again, I know that's a cliche, but it really is all about the people. I mean, I love technology. I won't lie to you. I miss technology. Getting to do it. That thermal battery program, actually, I worked on that as an engineer before I guess became management or an executive. So I miss technology. But at the end of the day, finding people, motivating people, we talked about in the beginning about attracting and retaining talent. That really is the most important thing. I'm a big fan of continuous learning. I always challenge my people to continuously learn. I think that's a trait we look for in people, and then a trait that we try and make sure happens in people, getting outside of your comfort zone, trying to learn something new.
So speaking of people, when you think about folks who want to join this industry, who are interested in national security, interested in defense, maybe as an employee, let's start there, and then we can talk about as a founder. What would you tell them to do?
Continuous learning is super important. I think the world is very multidisciplinary now. It's not like, you get a degree in mechanical engineering and all you're going to do is mechanical engineering or electrical engineering. So I think recognizing that and seeing where your passion is and not being scared to make a change. I mean, even for myself, when I was at Georgia Tech, I got a degree in material science. I actually worked on metals, so titanium alloys for fighter planes. Then I went to Stanford for grad school, still material science, but in Stanford it was all semiconductors and, Intel. I actually did an internship at Intel. So I pivoted from metals to semiconductors within the same degree program. And then when I was trying to get my first job, I was trying to move to Raleigh, North Carolina because my, girlfriend, fiance at the time was in Raleigh. So I was trying to find a job there. And there was really only two semiconductor companies there. So I applied to one, and he's like, we only are hiring double E's right now. We're not hiring material scientists. And I kept telling the HR guy, I was like, I've taken more than half my classes in double E, so you don't have to pigeonhole me as a material scientist. I can do the double E design work as well. And I kept calling him to the point that we were on a first name basis. And one time I got lucky, and the VP of engineering happened to be in his office. And the HR guy's like, well, you talk to Sameer, he keeps calling me. So the VP picked up the phone, talked to me for about 45 seconds. Like, oh yeah, he can do the job. Bring him in for an interview. And that's how I ended up getting the job. Which is maybe another lesson, is not taking no for an answer. And that's something that I tell all my employees as well, is not to take no for an answer. Don't tell my kids that. But I tell my employees that. So yeah.
Absolutely. And best ability is often availability. Be there when somebody needs something done, right?
Yeah.
It's fantastic advice. I'll ask you one more question, and then we'll wrap here. When you think about the future of CFD research, what are you excited about? What does the future hold for you all?
Yeah, so I'm excited. We've invested a lot in facilities. We don't even talk about in Huntsville, but in Huntsville, we built a 13,000 square foot lab. That's actually what that ribbon cutting picture is behind me on the TV.
Cool.
But we built a new lab. We actually named it after my late father, so we put his name on the side of the building. But that lab does biomedical research. We have a small dry room where we do battery projects, again, at an R&D scale in there. We do electronics work in there. And then we talked about our Hollywood facility and how we've got over 30,000 square feet of manufacturing space, prototyping space there. And then we just opened an office in Dayton, Ohio. And again, there's an integration lab in the back there as well. So I'm really just excited about all these new resources, which are facilities, equipment, and people, because we've grown. Like I mentioned, we were at 160 people only about 2.5 years ago. So we've grown from 160 people to 250 people. So I'm excited about all these resources, equipment, facilities, people, and the increased ability we have to satisfy our customers' mission and get technology out into the real world, helping the Department of Defense, NASA, National Institute of Health, and all our government customers.
That's what it's all about, right? Mission first. Sameer, fantastic. If somebody is listening and wants to learn more about CFD or wants to become one of the next tranche of CFD employees, where should they go?
Yeah, so our website is cfd-research.com. There's a careers page on there. I think we even have a video from some of our employee owners talking about what they like about working at CFD Research. We've got a Facebook page. We've got a LinkedIn page. So yeah, we'd love to have conversations about partnering or find new employees.
Fantastic. All right, we'll drop that in the show notes. And if you're listening on Apple or Spotify or another podcast, if you want to see the photo that Sameer is pointing towards and some of the other stuff that we'll have on screen, head on over to YouTube and subscribe. It's a better experience that way. Sameer, thank you so much for being here. Congratulations on all the success you've had so far with CFD. We're all excited to see what the future holds. The mission couldn't be more important, and we're glad you're in it. So thank you very much.
All right. Thank you, Noah.